Question number 7. Nuclei of an isotope copper has 29 proton and 37 neutron. So 29 proton and 37 neutron, the isotope is beta minus emitter. And what happens in beta minus decay? So for beta minus decay, neutron changes to a proton. Neutron changes to a proton, beta minus particle is emitted, and with beta minus particle, antineutrino is emitted. So with beta minus particle, antineutrino is emitted, and with positron or beta plus particle, neutrino is emitted. So with electron or beta minus particle, antineutrino is emitted, and with positron or beta plus particle, neutrino is emitted. And obviously, energy is also emitted. Now, state the nuclear notation in the form of AXZ for this nucleus of copper. So X is the symbol for the element. So the element is copper. So copper, there is copper, and A is the mass number or the nuclear number. So mass number or nuclear number is the number of protons plus neutrons, and Z is the atomic number or proton number, that is the number of protons. So mass number would be, mass number or nuclear number is the proton plus neutron, that is 29 plus 37 is 66, and the atomic number or proton number is 29. So we have expressed this. Now, the energy spectrum of beta minus radiation emitted by a sample of this isotope is shown in figure 7.1. So, number of beta particles and kinetic energy of beta particle. Use figure 7.1 to explain why other particles apart from beta minus particle are emitted during this decay. So, as we can see that kinetic energy of the beta particle is have a continuous range. Now, you have to know that for beta minus particle have a continuous range of kinetic energy. Continuous range of kinetic energy. So beta minus particle have a continuous range of kinetic energy, while for alpha particle, if let's suppose there is an alpha particle, then alpha particle has a discrete amount or the same amount of kinetic energy, so it would be a straight line. For alpha particle, they have the same amount of kinetic energy, but for beta particle, they have a continuous range of energy. Why they have a continuous range of energy? Because if we see the equation, then for beta minus decay, as we can see that neutron changes to a proton, electron, or beta minus particle, antineutrino, and energy. So here we can see that with beta minus particle and antineutrino is emitted, and so the energy is divided between beta minus particle and antineutrino. So with beta minus particle and antineutrino is emitted, so the energy is shared. So this energy is shared between beta minus particle and antineutrino. So the energy of the decay is fixed. So the total energy is fixed. So the total energy is fixed, but since energy of the beta particle have continuous range of values, because with beta minus particle, with beta minus particle, that is beta particle, and antineutrino is emitted, and so the energy is shared between beta minus particle and antineutrino. So the energy of beta particle have a continuous range of values. So beta particle have a continuous range of value, and antineutrino must possess the remaining energy. So the total energy is shared between beta minus particle and antineutrino. Therefore, beta minus particle have a continuous range of energy. So the total energy is shared between beta minus particle and antineutrino. So since the energy is shared, so obviously the beta minus particle have a continuous range of energy. State the name of the other particle emitted during this decay of the isotope. So as we can see that neutron changes to a proton, beta minus particle or electron, and an antineutrino. So an antineutrino is emitted. So another particle that is emitted is antineutrino. Then the copper isotope decays to an isotope of zinc. Give the radioactive decay equation for this decay. Include the nucleon and the proton number of all the particles. So initially we know that copper has a symbol of copper 6629, and copper is a beta minus emitter. So here, since it is a beta minus emitter, so one neutron from copper changes to proton and beta minus particle. So first of all, copper, that is 6629 copper, changes to zinc plus beta minus particle plus antineutrino. And since copper is a beta minus emitter, so neutron changes to a proton. That means now the proton number has increased by 1. For zinc, the proton number must have increased by 1. So as we can see that for this is the proton number, and for zinc the proton number has increased by 1, plus beta minus particle is emitted and antineutrino is emitted, also energy is emitted. So neutron changes to a proton, beta minus particle, antineutrino and energy. So copper changes to a zinc, beta minus particle, antineutrino and energy, and here neutron changes to a proton. And since this is a nuclear number, so proton plus neutron, and since one neutron has one proton, here we can see that proton has increased, so neutron changes to a proton. Neutron changes to a proton, so the sum of the neutron and proton is same. So the number is 66 and 30. So this is the overall equation.